we have already completed all the 4 types of flip-flops, and now this is the best time to move to another important topic, that is the flip-flop conversion, a very important topic for your exams. And what we have to actually do in the flip-flop conversion, a flip-flop is given to you, like in this example JK flip-flop is given to you, and you have to convert this JK flip-flop to D flip-flop. Okay, so a flip-flop is given to you and you have to get another flip-flop by small changes in the given flip-flop. So what are that small changes? We are going to determine these changes by these 5 steps, and we will implement all these 5 steps in this example, and we will try to convert the JK flip-flop to D flip-flop. At the end of the presentation you will find that you can do flip-flop conversion very easily. This is a very simple and very important topic. So let's start with it. Our first step is to identify the available and the required flip-flop. So let's see in our example what is the available flip-flop. The available flip-flop is JK flip-flop. So JK is my available flip-flop. And what is the required flip-flop? What we want D flip-flop out of JK flip-flop. So my required flip-flop is D flip-flop. So first step is now over, and it's a very important step, because if you switch these things, if you write available flip-flop as D flip-flop and required flip-flop as JK flip-flop, everything is going to be changed. Okay, so your answer is 100% wrong in that case. That's why this step is important and you have to take care of this thing. Now the next step is to make characteristic table for required flip-flop. That's why I told you to remember the characteristic table and the excitation table of every flip-flop. So please open your notes. If you have followed my lecture and wrote it down somewhere, then please open it, and if you don't, then no problem, we are going to do it right away. So the characteristic table for the required flip-flop, it means for D flip-flop we have to make, and the inputs to the characteristic table are Qn and D. So I don't know if you remember or not, but I remember that the output Qn plus 1 is same as D. So this is a simple characteristic table for us. Let's make it 0 1 1 0 1 1. Now Qn plus 1 is same as D, so it is 0 1 0 1. So our second step is now over. Let's move to our third step. In this we have to make the excitation table for the available flip-flop. So available flip-flop is JK, and now we need to make its excitation table. So first I'm going to make the excitation table here, and then you can follow Qn plus 1 and JK 0 0 1 1 0 1 0 1. So the values for J and K are 0 1 cross 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 1 0. So it is a way to remember the excitation table for JK flip-flop. You can also derive it from the truth table. Now we are going to use it. So let's extend this table and write here JK. Now when Qn is 0 and Qn plus 1 is 0, you can see J is 0, K is don't care. So 0 don't care. When Qn is 0, Qn plus 1 is 1. This case J is 1, K is don't care. So 1 and then don't care. Similarly when Qn is 1, Qn plus 1 is 0, J is don't care and K is 1. This case, so don't care and 1, and the last case is don't care 0. So now we have done with our step 3, and now we have to move to our step 4, in which we have to write the Boolean expression for the available flip-flop. So available flip-flop is JK flip-flop, and we will make the K map for it. So there are 4 combinations, so definitely we are going to have the 4 cell K map or a 2 variable K map. So let's make it first. We are going to require 2 such maps, one for J and one for K. Okay, and the inputs are definitely Qn and D. So Qn D, Qn D. Let's say my first K map is for J and my second K map is for K. Let's fill this map. For J it is 0 1 don't care. So 0 1 don't care, and for K it is don't care 1 0. Fine. Now let's make the groups. Before that, let me write down the values here: 0 0 1 1 0 0 1 1. Now let's do for j first, and my first group is this one, and I have already combined a single one, so no need to make this group. So j is equal to what? Qn is changing from 0 to 1, so j is equal to d. Now let's write down the value for k, and this is my group, and in this you can see Qn is changing from 0 to 1, but d is 0, so k is equal to d complement. Very simple. So we are done with our first step, in which we found out the values of j and k, the boolean expression for the available flip-flop. Now let's move to our fifth step, that is drawing the circuit, and this is very important step, so let's move to it. We have to first draw the available flip-flop, because we are going to do small changes in the available flip-flop to get the required flip-flop. So the available flip-flop is jk, and the two inputs are j, k, this is my clock, and the two outputs are qn, complement. So let's see what changes we have to do in this jk flip-flop to get the d flip-flop. You can see j is d, so if d is my input, so the j is going to be same, and k is d complement, so we have to use a NOT gate here, and it will be given to k. So overall you can see we are having our d flip-flop by using a jk flip-flop. Only thing you need to do is to find out this expression by following all these 5 steps, and then draw the circuit finally. So it's a very important and very simple presentation. You can do it by yourself. In the next presentation we are going to do some more flip-flop conversion. So see you in the next one.